My name is Patricia Barnett, and in this presentation we are going to conduct a chi-square test of independence. On our agenda, I will provide an overview of the process. We are going to examine the chi-square test variables. We will go over the results of the three tests, which will include two tests in which we found no significant results. So in the case where we do find significant results, we want to refer to Kramer's V. And we'll finally go over the significant results in the one test. We will go over some main takeaways. I will show you the reference that I used to prepare this presentation. And finally, we will close with any questions. So an overview of the process. Step 1, just as we did last week, we're going to open up PSPP and import the data. We're going to state the hypothesis, the rejection rule, and any supporting details, which would be for every test, the null hypothesis will state there is no relationship between the first categorical variable and the second categorical variable. And of course, as always, the alternative will state that there is a relationship between the first categorical variable and the second categorical variable. Chi-squared is the APA symbol for the chi-squared statistic. And of course, our rejection rule, we will reject the null when the p-value is less than alpha, where alpha equals 0.05. Step 3, we will run the results in PSPP and interpret them and conduct a post hoc Kramer's V if necessary. If we reject the null due to a p-value of less than 0.05, we accept the alternative, which indicates that a relationship does exist, and conduct Kramer's V to determine the strength of the relationship. So our variables for this test, what will we be researching in PSPP? We are conducting chi-square tests between three pairs of variables, as indicated in our assignment. Here are the tests, and the one I have bolded on the bottom is where we found a significant result. So our first hypothesis test will state the following correlational test was conducted, and the null, as always, is there is no relationship between the number of cars and the number of defaults. As always, our alternative states the opposite, that there is a relationship between the number of cars and the number of defaults. So what we found here on the right, after we ran the analysis in PSPP, which you will do in Analyze, Descriptive Statistics, and Crosstabs, is this chart over here. So the important figures over here are the n value, which you can see in the top middle, and toward the bottom under the matrix we have the chi-square tests. The Pearson chi-square is 6.68, so that indicates our chi-square statistic for this test. The DF indicates degrees of freedom, and the sig that we see there, two-tailed, very simply means the p-value. So, the chi-square statistic and its p-value were calculated using PSPP, assuming alpha equals 0.05. So we see that our p-value is 0.351, and that is, of course, more than our alpha. So we can determine that no relationship emerged with the chi-squared 6 degrees of freedom, n, which equals the number of cases, equals 6.68, and again that was our chi-squared value, and our p-value was 0.0351, which means no significant result was found. So we can move on to the next hypothesis test. So same thing, we ran the second hypothesis test, and the following correlational test was conducted. Again, there is no result between the Likert comfort and the number of defaults. And of course the opposite, that there is a relationship between Likert comfort and number of defaults. Once again, our output in PSPP gives us a n of 150, a Pearson chi-square of 6.68, degrees of freedom again is 6, our p-value is 0.351. So once again, this indicates that the chi-square statistic and its p-value were calculated using PSPP, assuming our usual alpha. And once again, no relationship emerged. We actually got the same exact results on the second test than we did on the first test. So that indicates no significant result once again. Since we know that we're going to have a test with one significant result, and we've ran the first two, we can assume that this next test will actually have a significant result and that we can accept the alternative that indicates there is a relationship between the two variables. In which case, we would use Cramer's v-table. So we use this when a null hypothesis is rejected to determine the strength of the relationship. And I just wanted to come to this first before we went over the third test, just to see what we're looking at on Cramer's v-table. So this table runs from 0 to 1. As we can see, 0 would indicate no relationship. But as we know, on this next test, we will have a relationship. So as it gets closer to 1, we can see that the relationship gets stronger. So with that in mind, we'll run our third test. Once again, the following correlational test was conducted. The null hypothesis would state that there is no relationship between the number of cars and Likert comfort. The alternative states that there is a relationship between the number of cars and Likert comfort. And finally, we have here on our PSPP output, that we can see a significant relationship between the two variables. So our n value is still 150 as it was in a previous test. However, we can see a much higher Pearson chi-square value of 450. Our degrees of freedom are also different in this test. They're 9. And we can definitely accept the alternate hypothesis in this case, because the p-value, as we can see, is 0.000. So it doesn't get any closer than that. And the other thing that we see on this as well that we'll want to refer to is the Cramer's v, which has a value of 1. And as I mentioned on the previous slide, a value of 1 on the Cramer's v test is very rare and indicates a perfectly symmetrical relationship between the two variables. So to sum that up, the chi-square statistic and its p-value were calculated using PSPP, assuming alpha equals 0.05. A relationship emerged, chi-squared with degrees of freedom 9 and the number of cases 150 equals a chi-square value of 450, a p-value of 0.000, and the Cramer's v value is 1. So in this case, Cramer's v indicates a perfectly symmetric relationship. So a significant result is found. So to sum this up, what are our main takeaways? The null hypothesis of a chi-square test can be rejected if the p-value is less than alpha, which is usually 0.05. If we reject the null hypothesis, we will examine Cramer's v to determine the strength of the relationship. And finally, in an APA formatted write-up, which is this whole long string, chi-squared indicates the chi-square test. The next value, which is 9 in this case, indicates the degrees of freedom. N indicates the total number of cases. The next value, which in this case is 450, indicates the chi-squared value or the statistic of chi-square. P, of course, indicates the p-value, and V indicates Cramer's v, which we can interpret using Cramer's v-table. Here's the reference that I used in the preparation of this presentation. And finally, in closing, please enter any questions in the comments, and as always, thank you for watching.